So for the first time since I guess GPT-2, OpenAI has dropped two open weights open source models. And today I will take you through the announcement. We're going to take a look at certain parts of the system card, and then we're going to actually test the models. Maybe not serious testing, but just to get the feel of these models that you can run on your own local machine if you want to. And if you don't know me, my name is Samer. I'm a Fortune 500 executive with 20 years of corporate experience, and I'm passionate about AI, teaching and learning, and I'm taking you on this journey so together we can get to the top 1% when it comes to artificial intelligence. And with this and without any further ado, let's get started.
Subscribe to Daddy's channel. The mic.
Okay, so this is the introduction page for GPT-OSS or US. I don't know how you should pronounce it, but this is the name of the family of models that OpenAI just released and made it open source and open weights. So they have released two models, the GPT-OSS 120B and the OSS 20B, both state-of-the-art open weight language models that deliver strong real-world performance at low cost. And both are available under the flexible Apache 2.0 license, and we're going to look at what does that mean in a second. But this is the license that these models are going out with. These models outperform similarly sized open models on reasoning tasks and demonstrate strong tool use capabilities and are optimized for efficient deployment on consumer hardware. And these are main things people look in such models. We want them to be strong in reasoning, really work well with tools when we build systems with them, and also they must be efficient. Again, this is the DeepSeek moment that changed everything, where efficiency became a big part of such models. These models were trained using a mix of reinforcement learning and techniques informed by OpenAI's most advanced internal models, including O3 and other frontier systems. The 120B model achieves near parity with OpenAI O4 Mini, which is a really good model on core reasoning benchmarks, while running efficiently on a single 80GB GPU. And that puts the model within the consumer-grade GPU for running it. On the other hand, the 20B model delivers similar results to O3 Mini on common benchmarks and can run on edge devices with just 16GB of memory, making it ideal for on-device use cases, local inference, or rapid iteration without costly infrastructure. So the small models are the ones that are getting super interesting because they do really well on benchmarks, and they are so light you can practically run them on any small computer that you have, on the edge, on the cloud, wherever you want it, at a very low cost. Again, they're highlighting that both models also perform strongly on tool use, few-shot function calling, chain-of-thought reasoning, and on health bench, even outperforming proprietary models like OpenAI O1 and GPT-4o. So those are small and super powerful compared to the size of these models and the fact that they are open weight. Those models are also compatible with the Responses API and are also designed to be used within agentic workflows with exceptional instruction following, tool use like web search or Python code execution, and reasoning capabilities. So again, they're stressing that these models are good in these areas, and it seems they are good in instruction following, which is something we know the GPT 4.1 is really good at. Now, this is where it gets really interesting. They are entirely customizable, provide full chain of thought, and support structure outputs. So when you run them and you prompt them, you are able to view the complete chain of thought of the model before it provides the answer. So all of that is exposed to the users of these models. So now let's take a quick look on how these models were trained and developed and their architecture. We're going to take a quick look in the blog itself and later in the system card for a little bit more details. So these models were trained using the most advanced pre-training and post-training techniques with particular focus on reasoning, efficiency, and real-world usability across a wide range of deployment environments. And here they're saying that while these models and others, including Whisper and Clip, are available openly, GPT-OSS models are their first open weight language models since GPT-2. So as I told you, since GPT-2, this is the first open weight model by OpenAI. Now here is a little bit more detail on how they architectured these models. So each model is a transformer which leverages mixture of experts to reduce the number of active parameters needed to produce input. The 120B model activates 5.1 billion parameter per token, while the 20B activates 3.6 billion parameter per token. So in reality, they call them 120B and 20B, but in reality, these models have 117 billion and 21 billion total parameters respectively. And these models use alternating dense and locally banded sparse attention patterns similar to GPT-3. We're gonna look at these concepts a little bit more in the system card. Also, these models use grouped multi-query attention with a group size of 8. We use rotary positional embedding, and this is the type of embedding they use within these models for positional encoding, and natively support context length of up to 128,000 tokens. So this is the context window, which is a big context window. And here, if you want to read this for yourself, you have all of the details in this table. So the models were mostly trained on English, text-only dataset with a focus on STEM, coding, and general knowledge. So those are the areas where model training was focused on. Also, they tokenize the data using a superset of our tokenizer used for OpenAI O4 Mini and GPT-4o O200K Harmony. So this is the tokenizer. Basically, this is the algorithm that breaks text into tokens, which we also open source today. So even that is something that is open source and you can look into, which is super interesting. And honestly, I might try to check it out myself. Now, for post-training, these models were post-trained using similar process used for O4 Mini, including a supervised fine-tuning stage and a high compute reinforced learning stage. And what they say is that their objective was to align the models with the OpenAI model spec and teach it to apply chain of thought reasoning and tool use before producing its answer. So the models are prioritizing the tool use and reasoning before giving an answer, which will improve its quality in general, and definitely that will show on benchmarks. And similar to many reasoning models we use through API, these models also have 3 reasoning effort settings: low, medium, and high. So when you're interfacing with them or interacting with them, using them locally or through a remote machine that you host them, you can always call them with different reasoning settings or effort settings of low, medium, and high reasoning. And like other models that are using this will trade off latency versus performance. So basically, you can have it slower but smarter in the way it answers, or you can have it super fast, but in that case, it didn't put such thought effort when it comes to answering your prompt. And it seems that setting this effort level is not typically like we do it with their other models, which has a clear setting in the API call that you make. But this is something they say developers can easily set within one sentence in the system message. So it will be part of the system message. So you prompt it to use which effort level you want it to use. So let's take a look at some of the benchmarks, which shows you how these models, while sounding as modest in terms of parameters, they are high-performing models, at least on benchmarks. So you can see this is the Codeforces competition code, and you have the models here. So these are the OSS models. Some of these tests were done with tools and some without tools. And you can see this is the 120B and this is the 20B, again, with tools and without tools. And they're comparing them with O3, O4 Mini, and O3 Mini. And you can see the 120B, which is the bigger one, with tools is ranking at 2,622 as a mark compared 2,706 for O3. This is impressive. O3 is the state-of-the-art model when it comes for reasoning in OpenAI. Yes, it's not the pro version of it, but still it's the dominant one in use, I would say, for plus users, and it is a super smart model. And this is pretty close to it in performance. And even the 20B model without tools beats the O3 Mini without tools as well. So one of those models is beating a really good model. O3 Mini is a really good model. If you look at the size of it and the speed of it, it's a really good model. So these models are super impressive. Now, this is a humanities last exam, and these are expert level tough questions, and this is a real benchmark when you look at reasoning models. And you can see that 120B with tools, and I assume here the biggest tool use is internet access or browsing, is ranking at 19% compared to O3 with tools, which is 25%. Still, this is an impressive rank for such a model that you can run potentially on your local machine. Even the 10 for the 20B without tools, it is again comparable to O3 Mini at 13.4 without tools as well. This is HealthBench, and here you can see that the 120B is neck to neck with O3 in performance. And the same goes for the realistic health conversations. It's 57.6, this is 59.8. It is neck to neck with a state-of-the-art model. This is super impressive for the 120B OSS GPT model. Again, in math benchmarks, it is ranking neck to neck with O3, O4 Mini, and O3 Mini. You can see the 120B is getting 96.6% compared to the best here, which is O4 Mini at 98.7%. And the same goes for the competition math. It's neck to neck with the best models out there for OpenAI. This is super impressive as a performance of such open weight models. And people were nagging a lot on them, and I think now they're gonna disrupt the open weight model or the open source model market. Again, same goes for science related questions and academic disciplines. These are high-level performances. You can go to the blog yourself and look at it in detail. Even the system card has more details around those, but these are impressive results. I think the point is clear by OpenAI that they're not just giving open weight models just basically to tick the box that they're going open weight, at least in part of their technologies, but they are giving super powerful models that you can run on consumer grade GPUs. Even for the small one, you can actually run it on your local machine. This is the Tau Bench Retail for function calling, and to my understanding, this is the benchmark that tests the ability of the model to call functions, regardless browsing, specific tools or functions that are created by users. And this is the accuracy of these calls. So you can see the GPT-120B is at 67.8% compared to O3, which is very good in that, which is at 70.4%. So all of these models, the open source models or the open weight models, are really good in function calling. Here again, they're showing the competition math benchmark. They're showing both models, the 120B and the 20B, and they're showing it against the chain of thought plus the answer length tokens. I assume these are the three different settings, so low and medium and high reasoning effort, and you can see the accuracy of answers. So it is very clear that the performance increases significantly the more reasoning you allow the model to do. So if it's the quality of the outcome is important, you better run it at high reasoning requirement for both of them. And you can see that the 20 billion model is as accurate as the 120 billion version of it. It just consumes more to achieve the same level of accuracy. Again, the same happens for the PhD level science questions. You can see both accuracy goes up with more reasoning effort. So the same story is here. Here they're spending more time talking about the chain of thought, and they're saying that our recent research has shown that monitoring a reasoning model's chain of thought can be helpful for detecting misbehavior as long as the model was not trained with direct supervision for aligning the chain of thought. This perspective is shared by others in the industry as well. In line with our principles, since launching OpenAI O1 Preview, we did not put any direct supervision on the chain of thought for either GPT-OSS model. And this is interesting. They say, we believe this is critical to monitor model misbehavior, deception, and misuse. Our hope is that releasing an open model with non-supervised chain of thought gives developers and researchers the opportunity to research and implement their own chain of thought monitoring systems. I think what they're talking about, and this is something they stress on in the system card, that chain of thought can reveal a lot behind the model. So even with the safety systems that they put in place when developing such a model, some of the things that you don't get in the answer, actually you can see in the chain of thought, on top of the fact that chain of thought could show some hallucinations. So people should be careful with what they consider out of the chain of thought if they decide to look into that. And you can see this is cleared here. Developers should not directly show chain of thought to users in their applications. They may contain hallucinated or harmful content, including language that does not reflect OpenAI standard safety policies, and may include information which the model is being explicitly asked not to include in the final output. So at least if you develop something and you put it out there using any of those models, you cannot share the chain of thought. This is something that OpenAI does not allow because of the clear dangers they're talking about here. And again, the last part, ironically, I wanted to cover here is basically OpenAI telling us why open models matters. And you can read this for your own, but they're preaching to the choir, I guess, the last people to come with such an open model. But basically they're saying, yeah, it helps in the development and the research, and it gives the people a chance to do great things with these open source models. So before I go to the system card, so this is what the Apache 2.0 license, I think they pronounce it Apache, out of Perplexity. This is a permissive open source software license that allows users to freely use, modify, and distribute software, including for commercial and proprietary purposes. It explicitly grants users rights to patents contributed by the software's author, which reduces legal risk for adopters. So to my understanding, one of the best licenses if you want to take this model, build a business around it or build a tool around it. You get lots of flexibilities and space to use this for your own profit, I guess. So this is at least from the quick description I got from Perplexity about it. But if you're building a product and you want to put one of these models, you better really understand the license and what it means exactly. So this is the system card for these models. You can read it. It's a big one. It has lots of interesting things. I will just cover what I found interesting beyond what was mentioned in the blog. So here there's an interesting table that breaks down the parameters of these models. You can see the 120B and the 20B. You have the MLP, which is the multi-layer perception. This is the size of the feed-forward network within the transformers of these models. You get for the 20B alone, so only for the feed-forward network, you have 114.7 billion parameters and 19 billion parameter, which is for the 20B. This is the vast majority of the parameters goes to this feed-forward network. And then for the attention, you get this amount of parameters. And then this is the embed and unembed. You can read about it here and before that in the system card. And then active parameters versus total parameters. And these are what we read about, that each token goes through an active number of parameters. This is the number again here. And then the checkpoint size. So this is the image of the model, the size of the image of the model. And they give it in something called gigabyte, which is nearly the size of the gigabyte. So when you see 60.8 gigabytes, I think this is how they call them. It's around a little bit more than 60.8 gigabytes in size. And the same goes for the 20 billion parameter. So if you download this model, if you decide to download it, by the way, the download link is on the blog itself. You can get it in Hugging Face. You can get it also in GitHub. It will be around 13 gigabytes in size as a model, I think, more or less. Quantization, again, this is something that became famous when we got DeepSeek. So here they're talking about post-training the models with quantization of mixture of experts weights to MXFP4. And for this format, weights are quantized at 4.25 bits per parameter. Again, here it's telling us that the mixture of expert weights are responsible for 90+% of the total parameter count. And using this format and quantizing these parameters enables the larger model to fit on a single 80 gigabyte GPU. So this is one of the main ways they are optimizing the model operation on smaller size GPUs, including the little one, which is the 20B. that can run on a 16 gigabyte memory. Now, if you remember, in DeepSeek, they used the FP8 if I'm not mistaken. So when you run the calculations in the transformer, you can run the whole thing on the 32-bit calculations, which is heavy and not in all cases necessary, not for all the calculations to get the attention and the details that you want before you push it to the feed forward and the mixture of experts. What at that time DeepSeek did, they ran it at many of these calculations at 8-bit, which optimized a lot of their training process. Now, the OpenAI team for these open weight model were running it on this format, which I'm not sure if it's something that is standard or they created for these open weight models. If you know the answer, write me a comment in the comment section. Again, this is a mixture of expert type of model, and each mixture of expert block consists of a fixed number of experts. So 128 for the 120 billion model, so 128 experts, and 32 experts for the 20 billion parameter model, as well as standard linear router projection, which maps residual activations to score for each expert. For both models, we select the top 4 experts for each token given by the router and weight the output of each expert by the softmax of the router projection over only the selected expert. So basically they use the softmax as the gate, I guess the gate for these experts, and activating which 4 experts are to be active per token. And the mixture of expert blocks use the gated Swee-glue activation function. So this activation function runs within each expert, and I think this just optimizes how these experts operate. I don't have that deep expertise. Again, write me if you know exactly what this does, but it could be something around the load balancing optimization for these experts. Again, here in the system card, you can see all of the details around the benchmarks that we already covered. I will not cover again. Here also, they give more focus on the pre-training process, and they say that the OSS models trained on NVIDIA H100 GPUs using the PyTorch framework with expert optimization Triton kernels. The training run for OSS 120 billion parameter required 2.1 million H100 hours to complete, with the 20 billion needing almost 10x fewer. Both models leverage a flash attention algorithm to reduce the memory requirements and accelerated training. So the flash attention, so the multi-head attention, when it's run through the transformer, it's a lot of heavy calculation and honestly not optimal, as this is something that all of the experts when it comes to training these models found out. There are many algorithms that you can run to optimize the size, the memory, and the compute need for running these training sessions when it comes to the multi-head attention calculations. So this is one of them. This is the flash attention algorithm. Again, when training the models, they develop their capabilities when it comes to tool use or function calling, and they worked with a browser tool, again accessing the internet, and then a Python tool, which is like a code interpreter for these models, and arbitrary developer functions, which is basically a function that you can develop yourself in an application that you're creating around these models. So whatever function you can design, these models will be able to call that function. If you are interested to know about languages, here they're focusing on the multilingual performance of these models, and you can see all of the languages that they tested to see how they perform with these languages. Again, you can see the low, medium, and high effort when it comes to reasoning, and they're comparing all of that against O3 Mini, O4 Mini, and O3. Now, if you're interested in the topic of AI safety, I recommend that you read the safety part of the system card, and it's good to get some insight in what OpenAI thinks about when it comes to safety. So here they're saying with these open source model, they are great. We give open source open weight models to the public. Researchers and developers can do great things with these models, and they can innovate even beyond what OpenAI did. But at the same time, that doesn't stop bad players from doing bad things with these models. And that was their focus in ensuring that they limit the capability of these models being used negatively by bad players out there. And one of the things they looked at when it comes to safety can these models be fine-tuned to reach high capability in the biological and chemical or cyber domains? And again, they do testing and checks on that, and they find out that it's not so easy or possible to really get something that is not already out there or super dangerous out of such models open way to the public when it comes to biological, chemical, or cyber domains. And again, they tested the model with disallowed content. They did tests where they asked the model not to mention certain keywords, I guess, and this is how they test it. And obviously, this is a test that they mentioned that the models passed. So it is following the system prompt instructions of what it actually reveals and doesn't reveal. So here they've tested the jailbreaking potential for these models, and we've seen this in the past, people putting weird text as part of the prompt and trying to get the model to say something that it shouldn't say or reveal information it shouldn't reveal. And this is again part of the testing that they've done, and you can see the jailbreak evaluation for these models here, and they compare it with O4 Mini. And for the most part, they are as safe as O4 Mini, which is there for a while, and which we know, or at least we didn't hear anything that anyone was able to do when it comes to jailbreaking the O4 or any OpenAI model that is out there. So again, some more detail on the testing that they did on jailbreaking. System prompt extraction, so someone trying to extract the system prompt from the model itself through prompting it. That's a super interesting concept when you think about it, and many people will try to do that. And then prompt injection hijacking, and this is basically trying to get the model, as I said before, to say something that it shouldn't say or take an action in theory that it shouldn't take. And you can see here is the benchmark of that testing that they've done. This is how O4 Mini performed, which is super safe. If you look at those, a bit behind, but overall, they are safe or deemed safe to go out models, but not as safe as the O4 Mini. Again, these are based on their own evaluation of this ability of hijacking the model. So if you read the details, they try to get the model to say access granted, and I guess in that test or instance, they're telling the model not to say access granted. So that's how they do the test. And if you, there's a lot to read when it comes about safety testing. I think half of the paper, the system card, is on safety, which is necessary and interesting, especially when OpenAI, after a long time, comes out with an open weights open source model. So here, they assess something super interesting. They assess the model's ability to self-improve, not natively within the model, but the test that they run or the check that they think of. Can someone out there take, let's say, the 120 billion model and then fine-tune it to do kind of AI engineering jobs that will lead them to make a much better version for the 120 billion parameter itself? And then obviously they're not worried about people who will do good in this area, they're worried about people who will do bad in this area. So the bad players in this area. And basically what they find is that when it comes to the software engineering bench or the OpenAI pull request bench, so all of these are evaluations, and the paper bench, against all of them, there's not a big issue, it's not a major issue, and there's no symptoms of really this model ability of self-improvement. Basically, you cannot get that model and try to get it to help you improve the model itself. That will not work. Now, in the blog post, they have the link for the playground for these models. And if you want to go to the GPT-OSS.com, you can test it for yourself. They're putting it public, and I think everyone can test them. And you can see here, you get the 120 billion parameter and the 20 billion parameter models. You can select which one you want to test. You can, I think, download them apparently directly from here. You can decide to show or not show the reasoning, and you can select the reasoning level. And you can simply prompt it and get answers from it here. This model doesn't deal with attachment. This model, unless you actually develop it into a system, can't deal with tools. So if I ask it to access the internet here, it will not fundamentally. I'll have to build the system, either code it or maybe potentially really soon in something like N8N, connected to tools like web browsing and code interpretation type of tools, it will use these tools in that environment only. So not to make this too complex, I will use some of these standard prompts that they have. So let's start with how far away is the sun from Earth. Even with high reasoning, it was super fast. And you can see we get the answer here, 149.6 million kilometers. And here it's explaining why. I don't know if this is the actual chain of thought. No, here is the chain of thought. You can see how far away is the sun. This is a simple factual question. We should answer it with an average distance. So you can see how the model is thinking. You can expose it or remove it. And again, if you're building your system, remember, OpenAI doesn't allow that you, for your users, show the chain of thought. So let's try something with Python coding. So write a Python function that checks whether a string is a palindrome. Okay, let's go for that and let's see the performance. It's a fast model and you can see it's a really fast model, honestly. Maybe in a different episode, or I'm sure others will test it really heavily when it comes to coding. Again, we can see the chain of thought, you can see it here. So I hope you enjoyed this. This is an interesting and it's a pivotal moment for OpenAI, I guess, and it will definitely keep the open source now players out there on the edge of their seats. OpenAI is no joke. When they come into the game, usually they come big, and clearly they're coming with really good open source models. It is super interesting to just watch this, how it plays out, what people do with such a model. On X already I see people doing amazing things with these models, and I hope you enjoyed the episode. You got a quick run on what these open weight models are about, how they work, what's the technology behind them, and if it tells us anything, even for the most part that OpenAI models are closed, we are not way behind in the general understanding. They have their own, cooking ingredients when it comes to training their models. But in the general sense of the methodologies they use to train and develop their models on a high level, without looking into their secrets, it is the same that everyone else is doing. Clearly the devil is in the detail when it comes to training these models, and I'm pretty sure all of these AI research labs have their own secret ingredients when they train these models to get their edge in their area that they want to beat everyone else at. So if you enjoyed this episode, do not forget to subscribe to my channel, hit the like button, share it with someone else on LinkedIn, Facebook, wherever you want, if you think others will benefit. And with this, thank you for watching and goodbye.
Subscribe to Daddy's channel. Give me the mic.